Welcome back, guys. We are learning Laplace transformation, and this is the part 2 of transform theory. And in this part, we are going to know what is Laplace transform. So, it is used to represent continuous time signals in the S domain. Now, what is S domain? S domain or the Laplace complex domain is a type of graph like this where like the complex numbers in complex numbers we have, so let's say the complex number is um t, for example. So t is equals to a plus ib, right? Where I is this is imaginary part and this is real part, right? And we had a graph, right, in which we had placed the imaginary and real parts. Similarly here, the real part is represented by a sigma and imaginary part is represented by omega, and real part is on the horizontal axis and imaginary part is on the vertical axis. This is the formula, a fixed formula for all Laplace transformations. Let's move further. Let's solve a question now. This is the definition of Laplace transform theory, okay? Now, we will solve this question where we have to find Laplace of 1. So here, f of t, our f of t becomes 1, right? Now, Laplace of 1 equals to 0 to infinity e to the power minus st, and here f of t will become 1 and dt. Okay, this is multiplication sign. Now, which will be equal to 0 to power infinity. Now we have to integrate this, but before that we will just sort this out. So it will be into dt, right? As it was into 1 and anything into 1 is the same thing. So here it will be integration of minus e to the power st dt. Now since we know that anything to the power e is the same thing, but if there is a constant ahead, we divide the answer with that constant, right? Like, so integration of this thing will be e to the power minus st upon minus s. This is basic integration and I will start its video soon. And after this, let's put this value or substitute this value, and so it will be equal to e to the power minus s into infinity. We are replacing this values in this t term, okay, upon minus s minus minus s into 0 upon minus s. Now this will be equals to e to the power minus infinity upon minus s minus e to the power 0 upon minus s. Okay. Now we know this is equals to 1 and this almost is equals to 0, right? And so our answer will become 0 to the power minus s plus 1 upon s. Okay. And then we can conclude that Laplace of 1 is equals to 1 upon s. Let's move further. Let's move to the second question where our f of t has now become e to the power a t. Okay, so we just start writing the answer, which is Laplace of e to the power a t 0 to infinity e to the power minus st into e to the power a t into dt, right? Now here we see, since the base is same, only the power is different, so we just add them. This is a basic property of exponents, and e to the power minus st plus at, okay, into dt. Don't forget this step. Now the next step is e to the power minus s plus a into t dot dt, since s and a both are constants, okay. Now this will be this will be equal to, like, we will integrate this term and it will be equal to e to the power minus s minus a t upon minus of s minus a, and the limits are from 0 to infinity, right? And so this will be equal to e to the power minus infinity upon minus s minus a and minus s minus a. Now this will again become 0 and this will become 1. So it will be 0 upon s minus a minus of s minus a, sorry, and we will take this minus down and s minus a. Okay, so we can conclude that Laplace of e to the power at is equals to 1 upon s minus a. Ignore the voice, it's of a truck passing by. I can't afford a big mic. So this is the answer of Laplace of e to the power at.